Hello everyone, this video is going to show how to complete a multiple regression analysis using Excel and how to interpret that analysis. So in the previous video we looked at a simple linear regression, which was this format from chapter 14. Chapter 15 takes that simple regression model and changes it to add more independent variables to try to explain more of that variation. So if we look back to our simple linear regression model, our R squared is at 80.9%. So about 80.9% of that variation is explained using just the one variable of sales. Okay, so what we're going to do in multiple regression is we are going to add more of those dependent variables or independent variables to see if we can figure out and explain more of that variation. So we're going to have multiple correlation coefficients. So what we look at to start out with is we're going to have to do a couple of tests. We're going to start the same way we started with the simple linear regression, where we've got all of our betas or all of our correlation coefficients equal to 0, basically saying that there is no relationship between the dependent and independent variables. Our alternative is that at least one of those betas, at least one of those correlation coefficients does not equal 0, which means there is some form of a relationship that exists. And this is going to be tested with that F statistic, just like in the previous video with the simple linear regression. So let's try it here. We are going to continue with our accounts receivable being our dependent variable, except for this time we are going to try and regress both sales and inventories on accounts receivable. So not only do we want to see if sales has a relationship with accounts receivable, we want to see if does the amount of inventory that you have relate to your accounts receivable. So the null hypothesis, again, is that all population coefficients are equal to 0, meaning there is no relationship, between the independent variables and the dependent variables, or dependent variable. So that's our null, and we're going to make this a little bit prettier. So then our alternative is the same thing but opposite. So all population coefficients are not equal to 0, meaning there is a relationship between at least one of the independent variables and the dependent variable. So that's our alternative. All right. So here's our null. We're going to just highlight them so you can see them. Here's the alternative. So how do we determine this? Well, again, we're going to use that regression model. So let's go into our data analysis, use the tool of regression, and this time we are going to change it. Our Y range is still that accounts receivable because we're still trying to see, is there some impact of sales and inventories on accounts receivable? But this time our X input range is going to be both sales and inventories because we want to see if both of them have any effect. Let's put we'll put it in F1 again. We want that residuals plot still. Oh, what did I do? Oh, I put two F1s there. There we go. All right, so now we've got our summary output from the multiple regression. We've got our scatter plots here. And again, I still don't know why it gives me the same upper and lower confidence intervals. So, all right, we've still got that multiple r, but if you look at your r squared here, remember the point of a multiple regression from back here. Where is it at? Here we go. Somewhere. Hold on. We'll find it. Oh, there it was. We consider more than one independent variable to try to explain the variation in the dependent variable. So if we look, when we added that second variable of inventories, our r squared jumped up about 19%, because now we're at about 99%. So that's a much better model. But before we can look at the model, we need to determine, again, can we accept or reject this null hypothesis? Look at that F test, F statistic, and the significance. When we look there, you should be thinking that, yep, we are going to reject that null hypothesis. Because our significance is below 0.05, which is our alpha that we is generally used, is 5.0, an alpha of 0.05. So we are going to say that all population coefficients are not equal to 0 from the alternative. And there is a relationship between at least one of the independent variables and the dependent variable. All right. So again, let's try to make this look a little nicer. We'll maybe make that a little bit bigger. There we go. All right. We'll look at those plots in a minute. So we've determined that there is a relationship there. So the next thing we want to look at is the coefficients. So just like in the simple linear regression, we've got these coefficients here that we need to pay attention to. Let's highlight those in orange. So those coefficients give us our model. So our y equals, so our dependent variable equals our intercept, which is 71.27 or 28, plus our sales coefficient of 0.05. X1 we'll say is our sales, plus our correlation coefficient for inventories of, we'll say 0.25, X2. So that is our model. That means if we plug in a variable value for sales and accounts receivable, we should be able to predict our if we substitute a sales and inventories value, we should be able to predict our accounts receivable. So if we, let's see, let's go with again, let's do sales of 2,700. 2,700. And our inventories, let's say, is 400. So if we take that equation, that's not what I wanted to do. There we go. And we actually type it into Excel as just an equals, we get $306.28. So if in the next year our sales inventory ended at 2,700 and our inventory was at 400, we would expect to see accounts receivable of $306.28. So that's how you would use the model to actually predict. Now, just to check, since we've got those null and alternative hypothesis that there is a relationship, we've got our model, but is that model worthy? Is that model actually usable? So when we find that we have a model that's got a relationship between at least one independent variable, we need to go and actually figure out, okay, which independent variable, both independent variables, what do we need to look for here? So what we need to do is go down and look at those p-values just like we did before of our two variables. Let's go with this color. It's okay. So because we see that both p-values are below that 0.05, we know that they're both significant. But what we actually did, let's go back here. So that was the first test we did, looking to make sure that there was a relationship. Looking at those second p-values is actually looking at the individual regression coefficients. So is there a relationship between sales and accounts receivable? Is there a relationship between inventories and accounts receivable? So let's go back in here and say that, you know what, even though you only ran one regression, you actually have three different hypotheses. So let's put our next null hypothesis here and say that the coefficients, the sales coefficient is equal to 0, meaning there is no relationship between sales and accounts receivable. So that's my null hypothesis. Again, all sales or not all, the sales. The sales coefficient is equal to 0 is your null. So then the alternative is that the sales coefficient is not equal to 0, meaning there is a relationship between the sales and accounts receivable variables. We'll just say between sales and accounts receivable. That sounds better. And we'll make that bigger. So here's our next null hypothesis and the alternative. And now we've got this same null hypothesis happening again, except for it's going to be the inventories coefficient is equal to 0, meaning there is no relationship between inventories and accounts receivable. And then the alternative is that the inventory coefficient is not equal to 0, meaning there is a relationship between inventory and accounts receivable. So by looking at these p-values, we know that we can reject both of these null hypotheses and determine the alternative is accepted and the sales coefficient is not equal to 0 and the inventory coefficient is not equal to 0. So there is a relationship between both of those variables and accounts receivable. So we will reject the null, both null hypotheses, yeah. Hypotheses, the sales coefficient, we'll just type all that in, is not equal to 0, so there is that relationship, and the same for inventories. And then we will make this look a little nicer so you guys can actually read it. All right, so that's what we do with those three hypotheses. And that's what it tells us about our three variables. Our independent variables of sales and inventories are affecting our accounts receivable. And we find those again by looking at the p-value or the significance of F and then the p-values of the individuals. When we look at it, again, we're seeing that our R squared is higher than it was when we just did the single one. So something else to maybe look at would be, well, let's run just a single on inventories on accounts receivable and see if that has any type of an effect. Does it give us bigger than this 99? Is it close to that 99? So let's actually just run that real fast. Let's come back. Let's take this and copy it to another page. Because one of the things is making sure that you get the correct model. So let's run a regression where we've still got our same dependent variable, but now our independent variable is just the inventory. So this is a simple linear regression. And we get an R squared of 88. So that R squared is closer, but we're still going up by about 11%. So we're going to say that the best model is this one with 2 variables. Again, if you get rid of one variable and it hardly changes that R squared, that one variable probably isn't worth it. Then the last thing that you need to check again is make sure that it is following those assumptions of regression. So go ahead and look at those scatter plots of the residuals. To me, they don't look like they've got any type of any type of pattern to them. They all look like they're pretty far apart in different directions, not looking like they've got a positive or negative linear effect or an exponential effect to it. So what we're then going to look at, let's go down. We've got our residuals here. Let's find our z-scores again. So we're finding our mean and then our standard deviation. So average all those residuals and then find the standard deviation of those residuals. And let's find our z-scores. Remember, it's standardized, the residual, the mean that is going to be absolute referenced, standard deviation, absolute referenced, and that's it. And then we need to construct a scatter plot using the z-scores and the residuals. And if we insert a trend line there, we find that we do have a fairly linear look at the residuals, which tells us that it is actually a normal set of data, and we should be able to say that, okay, this is a fairly decent model. Again, we look at ceteris paribus, saying that nothing else really considered, this is how it would work. We know that in the real world, yes, there are more than just sales and inventories that affect accounts receivable, but this should give you a fairly decent prediction of what you are looking at. Again, this is a multiple regression analysis. If you have any questions, please let me know.